Today we are going to discuss about the Gauss theorem. So according to the Gauss, the statement is the electric flux through a closed surface enclosing a charge is equal to 1 upon epsilon naught times the magnitude of the charge enclosed. So if you are going to write it mathematically, you will write that for any closed surface. So here we are taking the integrations of for any closed surface. Now E dot ds is equal to 1 upon epsilon times of the total charge enclosed. So the electric flux, now we know that E dot ds is a term which is known as flux. So this will contribute the flux. So for any closed surface, the flux is equal to 1 upon epsilon times of the total charge. Now in our definition we have included two important terms. Now first important term is your ds, and then we are putting the direction over it, that is we are taking it as a vector. So ds normally means area, and ds, and then we are putting arrow above it, it is known as area vector. So ds is known as area vector. So this is the first quantity which is involved. Second quantity which we are going to involve is your electric field, E. So E, again it's a vector quantity, and E represents your electric field. This is your electric field. When E and ds combine together, if you are writing only these two terms all together, it means ds is combined with E dot ds, we will get a term which is known as flux, and that is known as phi. It means dot product of two vector quantities, it's a scalar quantity. Now we can just assume that if we are having the clear knowledge of area vector, if you understand what is electric field, and if you know what's the meaning of a flux, then we can understood what is a Gauss theorem. So let's take an example of area vector. Now we are going to discuss about the area vector first. Now what's the meaning of area vector? Now we know it very well that area is a scalar quantity. So this quantity is your scalar. And vector quantity means it has the direction. So how you are going to connect direction along with the area? So this is a big question. It means that if you are going to combine these two quantities, then only you will write it as area vector. Now just assume one condition in which we are just assuming that suppose you are having a container like this. This is your container. This container is open from this end. Water is flowing from here. So what we'll find out, that the maximum content of the water will get inside here. Now in second case, what I am doing, I am taking another assumption. This is your container. Now water is flowing from here. Now when this water will flow from here, so it will flow like this, and then again the water will get inside this. If you just compare these two cases, what you will find out, the content of water is more in this case and it is less in this case. It means as you are going to rotate this container, the content of water which is getting inside is also going to change. It means direction here plays an important role, and hence we can say that as the direction is changing, then the content of water which is getting inside is also changing. So area is here termed as area vector. But there is still some confusion in the minds that actually what this area is. This area is your cross section area. This area is termed as your cross section area. Now exactly what does cross section area means? It means it is the area through which the water will come, right? Now second point is what will be the direction of it, because we are saying area vector, it also have the direction. So direction of the area vector is always perpendicular to the cross section area. Now let's assume these three different cases. These are the three different cases we are assuming. In all these three cases, what's happening, these are the containers, container number 1, container number 2 and container number 3. In container number 1, this is your cross section area, so perpendicular will be like this, So it working like a normal vector like this. So direction of this area vector is perpendicular to it. This also direction of this will be like this because perpendicular cross section area. In this case, this is your cross section area, so direction will be like this. So direction of area vector is always taken perpendicular to the cross section area. So now it becomes a vector quantity. So ds always means cross section. So if we are going to write in the mathematical terms, how you will write it now? So ds only represents your area, and when you are putting n and you are putting the cap on it, it becomes normal vector, normal unit vector. So it becomes your normal unit vector. So when you are writing area multiplied by normal unit vector, then it becomes your area vector. So from this it's very clear that area vector means cross section area when multiplied by a unit normal vector, then it becomes a area vector. Now second term, which important term which we are having, was your electric field. Now as per our previous knowledge, electric field means it is the area of influence of the charge. So it's just the area of influence of the electric charge, of the electric charge. Now if we combine both these terms, then it becomes the electric flux. So here if you are combining this electric field E and the normal vector ds, area vector, then it will become a flux phi. But we know that mathematically that dot product means EDS cos theta. So what is theta here? The question arises, what is theta? So theta is the angle between the electric field and the normal vector. So you are just going to take the electric field and the normal vector. Suppose if I am plotting the direction of the electric field like this is the direction of my electric field, this is the direction of my electric field, this is the direction of the electric field. Now here I am taking one cross section area like this. This is my cross section area. So what I will do, first I will plot a perpendicular vector on it. So this becomes my perpendicular vector now. So angle between this and this line will be now theta. So here this will be theta, right? So you just imagine that if you are having any surface, suppose this is your surface like this, this is your surface, right? Cross section here, it means container is like this. You just imagine of a container is like this, and the electric lines are going like this. These are your electric lines, these are your electric lines. You are just imagining it like this. These are your electric lines. Now if you are going to plot the normal vector, it will be somewhat like this. This will be a normal vector. So what is the direction between the electric field and the normal vector? So this will become your this angle, and it will be 90. So here theta is equal to 90 degree. So what is the electric flux here? Phi. Phi is E ds cos 90. So flux will be 0 here. अब इसको देखते हैं सर।